Hello everyone. Now we are going to implement full adder on the boolean mode. So first we need to create project. Then next project name. So I will write full adder. Next, as this is a RTL project, so RTL project. Next, then here we need to add our source. So full adder. This is our source file. Okay. Next, add constraint. This is optional. You can add your constraint later on also. So next, from here we can select our boards. So in this project I am going to use XC7S50 board. So this is XC7S50 CSGA3241. This is our board. So next, finish it. So module name I will keep it same. Okay, yes. So inside this module we need to write our code. So in the full adder there are three inputs. So I will take three input A comma input B comma input C, and there are two outputs, sum and carry. So output sum, output carry. So these are the inputs and outputs. Now we need to write expression for the sum and carry. So assign sum equal to, for the full adder, sum is equal to A XOR B XOR C, and for the carry, assign carry equal to A and B, or B and C, or A and C. So this is the expression for the carry. Now we need to save this file. Save file. Now we can verify our truth table of the full adder from the simulation. So I'm going for run simulation, run behavioral simulation. So from here we can give the inputs. So for constant A is, I will keep A is 0. Okay, then B is 0, C also 0. So these all three inputs are 0. So let's see what are the outputs will come. So run this. So 0 0 0. So sum is 0, carry is 0. Now I will change it. If A is 1, B is 1, and C is 0, then just run it. See, if A is 1, B is 1, C is 0, then our sum is 0 and carry is 1. Now take one more condition. A is 1, B is 1, C is 1. Okay, run it. So A is 1, B is 1, and C is 1. So sum is 1 and carry is also. Similarly, you can verify the other cases. Now I'm going for RTL analysis. So okay. Here we need to do input output planning. So in the scalar port, as here 3 inputs and 2 outputs, so we need to set these constraints. So for the first input, first I will show you the boolean boards. See, these are the slide switches which we are going to use for the input, and these are the LEDs where we can observe our output. So I'm in this full adder there are 3 inputs, so I will use these 3 slide switches, first, second and third, and to observe our output I will use this sum and carry. So some name is given here just below the slide switches. So these are the package pin we need to set. So here this is the first slide switch, so I will use, from the board you can set your package pin. K1, next one is the K2, last one is the L1. And for this input, these are the some input output standards. So we need to set this input output standard, and in these boolean boards, this input output standard is LV CMOS 33. So according to your board, you just set this input output standard. And output is, for output or package pin is B4 and A4. So here we set our constraints. This is left input output standard. So this is done. Now we need to save this file. Okay, so our constraint file is ready. Now we are going for run synthesis. So synthesis is completed. Now we need to go for the run implementation. Okay. So our implementation is completed. Now we need to go for the generate bitstream. So bitstream generation successfully completed. Now before going to the hardware, we need to connect our board to the PC. I will connect. Now go to the open hardware manager, open target and auto connect. So my board is connected. So this board is connected now. Now we need to go for the program our device. So program device, and this is the bitstream which is generated from the program. Now we need to dump this file to a program. So our bitstream file is dumped on our board. So now we will see on the board. So our bitstream file is dumped on this device. Now we are going to verify our program. So these are the three input switches, and here LEDs are given. So this is for the output. This LED is for the sum, and this is for the carry, and these three are the inputs. So if I will give 0 0 0, so sum is 0, carry is 0. If 0 0 1, then sum is 1, carry is 0. 0 1 0, sum is 1, carry is 0. 0 1 1, then sum is 0, carry is 1. If 1 0 0, sum is 1, carry is 0. 1 0 1, sum is 0, carry is 1. 1 1 0, sum is 0, carry is 1. And 1 1 1, sum is 1, carry is 1. So this is the all cases of the full adder. Thank you.